Hello everyone, welcome to GSS video tutorial series on BWSim-5G simulator. In this video, we are going to take a deep look into the concept of outdoor terrains and further analyze their characteristics. First of all, we need to understand that there are different kinds of terrains: rural macro, urban micro, indoor factory, and indoor office. In this experiment, we are going to see the first three, which is urban micro, and rural macro. Despite having previous experiments involving these terrains, this experiment will solely focus on the characteristic features of these terrains. First is the urban macro cell. So, what characterizes the urban macro is the two things. One is the densely populated terrain with tall structures which act as source of multipath fading. Secondly, base station is mounted to higher structures like buildings, cell towers, etc. And the transmitting power here is 43 dBm or 46 dBm. This is mainly optimized for higher network coverage at about 100 meter to 500 meters. So these are the factors which characterize the urban macro cell. The urban micro cell, on the other hand, is mounted on top of shorter structures like traffic signal, lamppost, etc. These urban micro cells are optimized for high capacity rather than network coverage. Typically, the transmitted power between 23 dBm or 30 dBm. Now, the third one is the rural macro cell. In the rural macro cell, base station is again mounted on top of taller towers, but the difference here is it is very sparsely populated with the tall structures that may cause multipath fading. And because of this reason, with the increase in distance, there is a very less sharper increase in the path loss or decrease in line of sight. These are some of the observations we are going to make in the experiment that we are going to do. The first observation that we are going to make is how path loss behaves for the three different terrains. This being a repetition of the first experiment but from a different context. Okay. Now the simulations required for the first observation is over. Let us look into the parameter in question, which is path loss. One thing that can be noted here is the sharper increase in path loss. It can be noted with increase in distance, the increase of path loss is much sharper in the urban scenarios than in the rural scenario. Can be attributed to the fact that as the distance increases, the different structures that contribute significantly to the path loss also increases, leading to this sharp increase, or to put it into other terms, the rate of change of path loss is higher in the urban scenarios. The next observation will be made with respect to LOS for the tree terrains. Again, as you can see here, the LOS probability decrease is more sharper in urban scenarios than in rural scenarios, and this can be again attributed to the fact that as the distance increases, the structures that cause obstruction for the LOS increases, causing this sharper decline. And the third observation that we are going to see is the shadow loss. One noticeable thing here is the shadow loss remains pretty much similar for all three terrains, because this is based on the log normal distribution, and all the three terrains have similar statistical properties with respect to shadow loss. And then we come across property called as the link gain, and it can be again seen that the rural scenario has a better link gain than the urban scenarios. This can be attributed to the fact that there is lot less factors contributing to the multipart fading, which in turn causes deterioration in the quality of the link. And finally, we analyze two more parameters, which are the channel gain and the coupling gain. And if you can note here, again, rural scenarios outperform the urban scenarios with respect to channel gain, because of the longer line of sight that is possible between the transmitter receiver in the rural scenario, which causes very less signal attenuation, therefore a better channel gain. And as far as coupling gain is concerned, again, the rural outperforms the urban scenarios because of the very reduced electromagnetic interference that are present in the rural area. Now that we have made four different observations based on four different parameters, and hope you have a clear understanding of how the three different outdoor terrains behave with respect to different types of gains. For any questions or problems regarding the implementation details, you can contact the Jigyasa team. I will meet you again in another video with another wireless concept. Thank you.